My name is Rodolfo Núñez. Everybody calls me Rodo, and I work at Entel, a telecom company, as a senior MLOps engineer. And I do not drink coffee, but I really like to drink water and hot chocolate.
Oh, the project structure. I think I really like that one, which is the idea of automating things instead of doing them over and over again. I want to look into that project directly. Actually, I'm a little bit greedy. I was like, give it to me. I'll steal a few things.
Yeah, maybe he can open source that. That would be really nice. What's going on, everybody? This is your host, Dimitrios, and today I am joined by none other than Abby. And today we are also talking with Rodo, who is what I would like to call a recovering data scientist. He has moved from being a senior data scientist into being a senior machine learning engineer at Intel, which is not the Intel that you probably think of that makes the chips. It's Intel, a company out of Chile, and they are doing telecommunications. So we talked all about different learnings that he has had going from being a data scientist into machine learning. It should almost be titled "What You Need to Know in MLOps If You Are a Data Scientist." And he had a few hot takes. What do you think about this, Abby?
I felt like I did agree with some of his takes, not with all of them. But I think some things were really interesting. The one part about automating the workflows instead of doing the same thing over and over again, even if it doesn't take a lot of time, but is a blocker. And the second thing, which was about reproducibility and the kind of almost OCD level organization that they have with projects, the interesting onboarding process they have with bringing new hires so that they can teach the culture side of things. And the culture isn't, hey, we need to have a coffee every Friday and you need to say 2 nice things about your team members. The culture is more,
which is also nice culture, but that's not the key culture that we're talking about in this respect.
You're asking.
You don't like hanging out with people. If you don't like people, then that might not be the culture for you. Exactly what we're saying. But it is true that this type of culture that we're talking about with, you need to do these things like this. Here is your cookie cutter template that you're going to use, and you should know a few of the essentials, as we called it. And we really jump off this conversation with the essentials, which are data scientists and what they need to know to be dangerous beyond just data science. I mean, obvious one there is Git. The other one is just some kind of version control, and it goes back to that reproducibility you were talking about. So I loved that. And then he talked about the clean code methods and how you need to be thinking about clean code. And he went into the 2 different camps of, should you be commenting your code, or should your functions be self-explanatory, or should your variables be self-explanatory so you don't need to comment?
Now life is easier. With GPT-3, we can comment the code automatically.
There we go. So it's even easier, and now there's no excuse to not be commenting your code and having this clean code. And even, I mean, with GPT-3, I've seen some examples of people saying, update my code or make it better, right? What is it? Refactor my code. And GPT-3 will give that to you. So you, as a data scientist, if you are not feeling strong about your code, just throw it into GPT-3. Hopefully it's still free by the time this episode comes out, and you can refactor your code. And do not trust everything that it comes out with, because I've seen too many outputs from GPT-3 that are absolute bullshit. That is a whole nother story for a whole nother podcast, though.
Well, March is sort of the time of release of the next GPT version. I'm not too sure if this episode will be released by March, but there's going to be next GPT.
Ooh, we'll see. We'll see how that goes, and we'll see if it has a little bit better accuracy. So as far as this conversation goes, Rodo was awesome. I really appreciated his outlook and his views on things. Hope you do too. Before we jump into it, I would like to say that we have so much going on in the MLOps community, and so many people tell me that they do not realize all the cool stuff we have going on. So I'm just going to list a few things that we've got happening. You might want to check out the virtual meetups that go on Wednesdays every other week. all kinds of good stuff. And if you're a visual person and you like to see system diagrams, or if you like to do little hands-on workshops, we're doing them at the virtual meetups Wednesdays at 6 o'clock CET. That is 9 a.m. in California, and I think it's 12 p.m. in New York. And then we've also got 3 different emails that are happening. And I just started posting a ton on TikTok. So if you do the TikTok thing, come and follow me over there. And last but not least, we've got a blog, and there's so many good things. If you like to read and you're not into the boring blogs that are talking about what is MLOps and you want to go a little bit deeper, that is what our blog is for. Without further ado, let's get into this conversation with Rodo. Let's just ease into it with this, all right? This is where we'll start. Let's ease into it with your take on why data scientists should know how to code and code properly.
Well, at the end of the day, data scientists are building software, very specific kind of software. It's a software that takes data, transform data, and outputs a model or a prediction or whatever it is. It's not always with machine learning, sometimes it's with other tools. But at the end of the day, you want to get a product out, and it has to be useful for people, right? So if data scientists do not know how to properly structure, and I mean the basics. I'm not asking data scientists to be like pros at coding. No. I mean the basics, the very basics.
What are the basics? Git?
Yeah, Git, absolutely Git. If a data scientist is working without Git, I immediately tell them, hey, wait, no, stop right there. You need
Red
to start
flag.
using Git, or maybe another tool. Maybe, I don't know, SVN or Mercurial, although I think Git is better. But what I mean is you need to be using version control of a good version control tool, not the Untitled 1, Untitled 2, Untitled 3. No. So that's the step 0. You need to be using Git or something like that. Another very basic point for me is good naming of variables and functions and stuff like that, because this is and now I'm going to talk about kind of 2 different schools. There are people who usually say that you should comment everything on your code, so or not everything, but a lot. So it is clear to other people who will then read your code what you wanted to do, why, etc. And there is another school that says you should not be commenting code because it should be self-documented. I'm more on the second school. I like to write code in clean manner with good names for variables, good names for functions. For example, I use for booleans, I always use the prefix is or has or something like that, so it is clear that it's a boolean because you are basically asking a yes or no question. And for variables, I tend to use kind of not too long variables, not too long names, but I don't use just df, for example, for a data frame. I think people should name their objects, their classes, or whatever they want in a way that it makes it easier to understand when people are reading it, and no matter where you are reading, because sometimes let's say you define a data frame at the beginning of your code, and then you use it on, I don't know, 100 times during your whole code. And you are using another data frame that you use maybe in half those points. It's if you name it data df and the other one data, it's very easy to mix up. So in general, I want to give data frames like last names or something like that, like data frame underscore raw to know that this is the first data frame that I read, or data frame underscore missing values cleaned. So I don't have to explain to you what is that, because the name tells you what is that.
Yeah, it's inherent.
And that way you can more easily share your code to other people, to other data scientists, to other MLOps engineers, or to whoever is going to take that code and use it in any way.
Yeah, speaking of sharing, I have to give a shout out to Will, who won the greatest award in the MLOps community for 2022. It was the most cringe thread. And what he mentioned in this thread was that I just watched a data scientist copy and paste code from a notebook into VS Code, save the file to disk, and email it to us so we can put it into production while he's on vacation in Hawaii. That is a team player right there. That is a data scientist. That is the exact opposite of what you are asking for. And what I'm wondering is, how did we get to that? Like, how does a person like that survive in the workplace?
Yeah, well,
your mind is blown. You're speechless right now. You can't even think of words.
I have a strategy, and where I work, we usually hire a lot of junior data scientists. So most of them already come from, I don't know, school maybe, or boot camps or whatever, and they are used to work on Jupyter notebooks, or they don't know how to use Git, or they just know Git exists, and that's all, the very basics. So what we do, at least, and it's useful in my opinion, is to have a very structured onboarding process, everything well documented, and at the very end of that onboarding process, we give them kind of an assignment, and it's a standard project. It's the project that every data scientist that enters our team has to do. There we kind of force them to use good tools. We force them to use Git because they need to get the project with that. They need to create their own repo and push everything. At the end of the day, we want them to know the basics of Git. Again, we don't want them to be pros. No, it's not necessary. We don't even talk about pull request or stuff like that. It is necessary at the end, but we don't start with that. We just want them to know the basics. And after that, we give them a template for projects. We develop in-house a project template for data science projects, quite open, I mean, quite general, and I think every team should be doing something like that. Every team should have a template already set up, and it will depend on the team. Some teams will need more of some stuff, and other teams will need other stuff, but you need to have a structured way to work together. So people who join in the team get easily kind of the culture of the team, and they can adapt, and then they can easily share that with more senior members, for example, and the senior members can review that code and give feedback in a more streamlined manner.
Interesting, because this is something, well, it's always talked about as one of the best practices, which is let's work with templates. And there's one very interesting template that is out there for data science projects, at least the one that I've been using, which is basically something called Cookie Cutter Project. I don't know if you checked that out, but there are plenty of those. But one of the big differences is different companies have different stages of data science projects and different team sizes as well. How do you make that distinction as to not every data scientist is supposed to write production level code, or not every code is supposed to be pushed into production. What's the distinction factor for you where you decide this is where we spend a lot of effort on writing unit tests, writing integration tests, and sort of working with more of like an object-oriented design, working more so with abstractions instead of encapsulations and all that stuff? Where do you think about software design, and where is it a data science project?
Well, at the end of the day, the final objective is to create something that is useful for the enterprise, for the market. So the answer should depend on that. Sometimes when we do things kind of too perfect, we end up not doing it because we take too long on doing it, and at the end we don't finish anything. I think it's very important to find the balance there, and some projects can be much more easier to go than to put into production. They don't need to follow too strict standards. I still think we should follow kind of the basic standards, which I already talked about. But I think in general, it's not a problem to not work with classes or stuff like that. Most of the projects that we develop on my team, at least, are basically a series of scripts that at the end of the day produces an output, and the objective is to take that output and put it into production. The way you do that, it's not that important as long as you manage to get that product out. So we don't always use classes, we don't always use oriented object programming, etc. It will depend on what we need to do. If we need to maybe create a tool for others to use, then it could be more important, because it has to be pretty general. It has to be useful for many other people, many other data scientists. For example, if we are creating a tool for data scientists to monitor their models, it has to be well structured and maybe with classes and everything like that. But if you are just getting a score for out of a model and you want to score clients with that, it's not necessary really. You can just run a series of scripts in a certain order, and if they are well self-documented, and the MLOps engineer who takes that can easily understand all of the steps and put that into production and get value out of that project. So it will depend on that, on what's your final objective, and do you really need to use more general programming?
I see. And also one of the things that you do talk about a lot, especially I've seen in your LinkedIn post and some of your other comments, is you've been sort of an ambassador for our Markdown and Quarter. So do you want to talk why should we be using those over using, let's say, Jupyter notebooks?
I started programming on Python at the very beginning, like kind of at school. And then I switched to R when I started working. Then I was like working with both languages sometimes. So after working a lot with R and a lot with RStudio, because if you are using R and you are not using RStudio, you're probably not doing it right, because RStudio is kind of the best IDE for R. Visual Studio Code is pretty good for general purpose also, so I tend to mix both of them. And when I started working again more in Python, I started noticing a lot of deficiencies on the basic Jupyter notebook structure, because I was constantly comparing it with R Markdown or Quarto. Quarto is more new, so I was not comparing it to Quarto at the beginning. But some of the pros that has R Markdown and Quarto, which are very similar, are that you are not writing your output inside the same document that you are coding in. for example, in Jupyter Notebook, you write a cell, you run that cell, you save the file, and the output of that cell is automatically saved inside that interactive notebook Python file. But so if you open that file with a text editor, you will see that at the end of the day, it's just a JSON file with a bunch of nonsense. Basically, when you save and upload an image, you get a bunch of nonsense because you are saving an image on a JSON file. So you need to write a lot of random characters, kind of random, to save that image. So the computer can interpret that. But on R Markdown, you don't do that. You get your output in your code editor. Your file is just code. Your file is just the Markdown code that you wrote with the Python code or R code or C++ code that you wrote, etc. And you can mix all of those in the same document. You can very easily create a cell for Python, and then the next cell is for R, and then the next cell for batch, etc., etc., etc. Code in Jupyter Notebook, in contrast, you need to choose a kernel, and you can run everything with that kernel. Maybe you can mix, I'm not sure. I haven't done it. If you have, please tell me. But at least as far as I know, you need to choose a kernel and run everything with that kernel. You can run R, you can run batch also on Jupyter Notebook if you change the kernel, but you need to choose one. On RStudio, R Markdown and Quarter, you can choose whatever you want. So it's much more flexible. And going back to the problem with saving your output on the file, that is really a pain on the ass too, because if you try to commit that into a Git repository, you will very quickly start to use a lot of memory, because when you change a plot, every time you change a plot and you commit that, you are committing the whole plot, and the whole plot is, I don't know, maybe 100 lines, 200 lines of code that change, and maybe you only change one point. Maybe it was a scatter plot with just one difference, or maybe you change the limits of your plot, and that will save a whole new plot, and that will happen for every one of your outputs. If you plot a data frame or a head of data frame, you will also save that data, and if you commit that and you send it to your repo, if you are working with on an open repo, for example, you could be filtering out sensitive information that you shouldn't, because one thing is to share your code. Maybe your code is open source, or maybe your code is private, but another whole different thing is to share data. Sometimes you are working on an open project but with private data, and with Jupyter Notebook you could sleep some data. You could be falling in some security issues.
For me, you spoke about these different, basically the templates that you have for the data scientists, and you also are talking about R now. And I know that you mentioned you're very proud of a setup that you have put together with a few other of your colleagues. Can you walk us through what that setup is and what it entails, and why it made you so proud to have put that into practice at your current job?
Yeah, when I started working as a data scientist about 6 years ago, I think, my first assignment as a junior there was to put in place many of the tools that we were going to use forward, because I was the first data scientist on my job. I started digging like best practices and stuff like that, and I found a pretty good video. I don't remember who was talking, but it was a video about good practices about on data science from 2017, maybe 2015, quite old. And they show up a project template that it made sense for me, but I felt it wasn't complete. So I heavily based on that and started adding progressively a lot of things. And with a lot of iterations, with talking with other coworkers, we ended up with a project template that is, in my opinion, pretty general. You are not too forced to do stuff one way or not or another, but it gives order to the project. So the basic idea is that when you are working with data, you are working kind of with a data flow. So let's speak about data in the general sense. You can have data as data frames, or CSVs, or whatever storage you have your data on, or maybe images, or maybe just config files. Everything there is data at the end of the day. So what we try to do is to have a pipeline of many scripts that take an input data and gives you an output data. So every script, maybe with a couple exceptions, will take input data and will give you output data for that script. And then the next script will take maybe input data from the last script and maybe from other sources and output something else, and so on. That is very useful in my opinion, because when you are running a whole pipeline, if your pipeline breaks at some point, you will know where it broke, and you will know, okay, at least I have everything up until there correct. I need to debug this section, this script, and then I can run from there to the end. It solves something that I hear many people who use Jupyter Notebook talk about, which is that with Jupyter Notebook you don't always have to run everything again, because it's there in the output. And what I always say to them is, why don't you save your output to a folder, a specific folder? So there we are solving that problem, and each file has a certain output. So if you have a lot of outputs, it could be kind of messy at the end of the day, because you could have, 10 output files for one project, because you have 10 scripts. So it could be messy to know where each output comes from. So what we do is that each time a script saves a file, it saves it with a prefix, and that prefix, it's kind of the ID of that script. We write pipelines with specific prefixes, for example, A00, A01, A02, etc. So whenever you see an output with the prefix A02, you know that the A02 file produced that output. So if that output is incorrect, you already know where to go look for, where you need to go debug or study. Another very important point is to modularize your code. In our team, we try to break our whole process into many different scripts, so we have these checkpoints. For example, we can have the pre-processing broken down to 10 different steps. First, we read the data, and then we read another data, and we mix it, we merge the sets, and then we take that in another script and clean the missing values or duplicates, etc., and so on and so on. Each script should be doing one job, kind of like functions, but not that much. We use a lot of functions inside one script, and so it's not that specific, but it's very useful, because you know that one script is going to be doing one job, and the job that it's doing is also in the name of the script. The name could be A00 underscore reading first dataset dot whatever, dot py, dot r, or whatever. So it's a very tidy way to organize projects, in my opinion, and also it allows you to mix many languages together, because every script is independent. So if you want to mix a Python script with an R script, it's very easy, because you just write your Python script, which will have an input, will do something, will have an output, and then that output you can read it with an R script and do something with R, have an output, then you read that with another script with whatever language you want, and go, and so on and so on.
One of the questions I have on this one, because it does seem like a very good way of thinking about problems, instead of just doing things randomly. One of the main reasons, or one of the things that I've seen, is sometimes one of the core data scientists that is working on a project leaves midway, and it's very easy to bring on, if you already have such an existing structure, it's very easy to bring on a new person, or for everybody else on the team to sort of pick up the work from where they left. But one of the things I wanted to ask you on along these lines was more so, how much of all of this is documented? How much of the script, how much effort is put into the script documentation and everything, so that everyone knows what is the real significance of this? Also, another thing, which is basically do we really need this script? How do you sort of identify that you're not putting too much effort on designing structures that could probably be just like a one-time use?
On this project template we have a lot of folders, different folders. For example, we have the files folder, where we have everything basically that we don't want to commit, the data sets or documentations or references to papers, logs, figures, the models, the object of the model that is saved. Everything it's saved on files on different subfolders, which are data sets, documentation, and model output. And on model output, we have the object of the models on one folder, logs on another folder, figures on another folder, reports on another folder, etc. So it's very easy to go and find whatever you are looking for. The data sets, we separate them on input data, intermediate data, and output data, and we could add more layers if we want. And there is, and out of files, we have many other different folders. For example, we have the pre-processing folder, where is all of the pre-processing for whatever you are doing. The model folders, where you have the scripts for the models that you are working on. The reports folder, where you have the scripts for the reports, not the reports itself, because those are saved on the files folder, but the script of the reports. And we have also more folders that I'm not going to get into right now, but we have a sandbox folder. So whenever you are starting a script and you don't quite know where it's going to land, or if it needs to be split on two or whatever, we usually develop that on the sandbox folder. And everything on sandbox, it's not official. When you receive a project from us, everything on sandbox, you can delete it, and there's no problem. But you can start working on sandbox, and when you already know what you will need, what you are doing, how much splitting you need to do, then you split that in, I don't know, 2 scripts, for example, and you place them wherever they need to go.
This also makes me think of a very interesting direction that we're going towards, which is one of the more popular books in the field, which is basically From Monoliths to Microservices. I think that's sort of where we're taking off, which is developing particular APIs for different things. Because you're managing everything so well, you can easily containerize it and debug individual parts as well.
Yeah. That's another important point. We put everything there on a container, so it is easy for it to run on whatever computer you are using. and with virtual environments for every language, because you can have a virtual environment for Python, another virtual environment for R, and it's very easy to set up both of them, and that way you can have no troubles when you put that into production.
Now, Demetrius, if you want to go into Kubernetes, you can have more questions as well.
No, I really like the fact that you spoke about reproducibility earlier, and now this seems like you're organizing everything so that reproducibility is that main player and it's in the forefront of what you're doing. Mm-hmm. Did you get burned enough times to where you realize that needs to be very much a part of what we do, or was it just something that came from software engineering that you had in your blood? How did you realize that reproducibility was so important, and then why have you started implementing it, or what other things have you done to implement it besides these scripts that you're talking about?
I'm not quite sure where it started, but I like to think problems in a broad in a general manner. Maybe it was a little bit influenced because I studied math, so when you study math you have to abstract yourself quite a lot and think about random bizarre spaces.
Yeah.
So I did not study computer science, but I really like it. So that influenced it a little bit too. But I did have some troubles on some projects because I needed to run something manually for a specific project. So every day, every month, I needed to run something, and it took me like 2 days to run that every month. So it wasn't too much, but it was annoying. I was just losing my time. So I started thinking how I can automate this and do it in a more general way. So I think all of these factors contributed, but I'm not sure if there's a kind of a particular one that was more important.
Another question is, let's say, I don't know if you do, but you might have some scripts to be able to manage the events and stuff, which is the entire event processing side of things. How often do you cater to the schema changes on that one?
What do you mean with schema changes?
So anytime you're working with any sort of events, there are schema changes over a period of time with your events, which is wherever you're pulling your events from. How often do you sit as a team and go like, okay, let's go into the code, work on the new changes that have been made in the source where we're pulling our data from, and now let's make sure everything's sort of adapted to that.
With events, you mean like kind of GitHub Actions or stuff like that, or what kind of events are you talking about?
So it could be something like ETL events. So not essentially on the CI/CD, but more so around the data acquisition side of things, because that's where a lot of changes have happened, at least for me, which is anytime we're working with a lot of integrated services. Let's say we're using 4 different services that are one for a payment gateway, and maybe this more so happens with, because I've worked with e-commerce companies specifically. I don't know how much of it happens at your work, which is you're working with different services and they have changes in the code, which changes the schema for you. And that would make sure that you now have to sort of adapt all of your scripts accordingly.
Okay, so you mean if something changes in kind of the data or the structure of how things should work, or moving to
the API
some other
changes
place,
and all of that stuff. Yeah.
Okay, we don't work that much with APIs. We work with internal data. I work for a telecom company, so we have all of the information in-house. What usually changes, although, is some ETLs, not usually, sometimes ETLs change, and we need to adapt. We need to correct these models. And what we are trying to do, but we are not yet doing, we are starting, is to implement a library called Great Expectations, which is very useful to assure that your data quality is maintained, and if it's not, it will tell you. It will give you an alert, and I think it's very, very useful. And we are starting to use Great Expectations, and the idea, at least, is to use a couple checkpoints in the whole process. For example, at the beginning of the model, at the beginning of the kind of the pipeline of the model, we want to check if the raw data set has still the same structure, the same columns, the same data types, etc. And at the end, we want to check that the model is outputting the kind of the same structure of data, maybe with a given distribution or something similar to that distribution. And in between, we can place a couple more checkpoints to, for example, to check that the model, when you give the data to the model, you are giving it the right data, you pre-process it in the right manner. So at least these 3 steps are very important in my opinion, and it's very useful to control those changes in kind of the ecosystem.
You said you have a lot of in-house data that is entirely owned by you. How do you have like a data cataloging solution? Is it built in-house for your team, or do you use an external one? Also, what are some things that you've learned along the way, which is how to build the right kind of data cataloging solution? Because I think one of the things that a lot of people don't talk about as often is the quality of your code is not directly dependent on the number of hyperparameters or the newer, sexier model, but actually on the quality of the data itself. And that's where we sort of need to put in a little bit more effort.
We did have a data catalog, but it was internal, like built in-house. But now we are moving to a new data catalog for the whole company, because the one that we were using was only for the analytics team, not for the whole company. But now we are working with another company to build a data catalog company-wide. I'm not working on that directly, so I don't have the details. And even if I had, I don't know if I could share them. But I know that there are people working on that.
So I want to go back to something you said earlier about the data flows. And you mentioned, let's look at data as if it was this idea of it flowing and going from one place to another with the inputs and the outputs. And then you don't have to think about, am I using R on this piece of data? Am I using Python? It's all just going into something, flowing into something, and then flowing out of something. Yeah. How else have you been thinking about that? Or how else have you been generalizing that idea and using it when you're designing the system that you're working with?
There's another folder that I didn't talk about, which is called pipelines. And there we have the most important files because there you build the real pipeline. And I mean the pipeline for development, not for production necessarily. But there the data scientists can call each script in a certain order. If we are working with parallel processing or with serial processing, it doesn't matter much in terms of writing your script. It will always be serialized. You always write things in a serial manner. Even if it runs parallel, you have to write something before the other one, right? So in those pipelines, you can call every script you want, run them in parallel maybe, or in series. And at the end of that script of pipeline, you can output all of the kind of the accumulative log of every file, and you can print how much time did it took for every step, for every script, etc. And I think that is very useful because you can then write in your README, your Markdown README of the project. You can write a section on how to run this project, and it's basically just run this file. If maybe you have a lot of pipelines, and each pipeline is for a specific task. So you can say, well, if you want to give a score for every client with these parameters, just run this script and you name it, and that way that pipeline will you will know that you have to run that pipeline, and that pipeline will do all the job. It will call every script. Every script will take their inputs and give you their outputs respectively. And when you Dockerize that, you just have to run one line of code, Docker run, and you give the path to that pipeline that you are interested in. So it's pretty easy to put into production afterwards. The MLOps engineer doesn't need to understand everything that is going on in there, as long as the data scientist understands it and makes sure that it's well structured. The MLOps engineer can just take it and run that line of code, and that's all. The project will work as the data scientist intended, at least.
So as far as this goes, man, there's so much for me to chew on here that we've talked about, and I really appreciate all these different insights. Now that we're getting to the end, I know that you had a ton of stuff that you mentioned you could talk about. We hit almost everything, but is there anything that you wanted to talk about that we have not hit yet while you're thinking? You mentioned to me, these are the things that I end up talking with people about and I end up having strong opinions on. And so I think we could talk about them in a podcast. And you do not need to say any more to me. If you want to do that, then I'm all in.
Yeah, maybe there are two topics we haven't talked about. One is the fact that I really think the elbow method, this is more for data scientists, not for MLOps engineers, but the elbow method, it's just a lie, it's an illusion. And the other one is agile methodologies. Many people don't like them. I don't like the agile methodology as a kind of a Scrum, but I think there are a lot of very good things that you can get out of that and use for your team. Those are the two topics I think we haven't talked about.
So what is, can you break down the elbow methodology and let us know why you have these opinions?
It's easier if you visualize it. So if there are people listening to this on Spotify, it won't help to share screen. So I just recommend you to create a vector of I don't know, from 1 to 10,000, and then get the exponential of negative x, where x is the first vector, and plot that. You will get a shape, a pretty well-known shape, which is very similar to what we usually get when we are studying clustering, and we plot how much more information we are getting out of one more cluster. So just take that shape and then ask yourself, where is the optimum cut, where you gain enough information so it is worth it to split one more your groups, and you will get a value, whatever value it is, it doesn't matter. And then ask yourself, well, maybe you tried 5 groups, 1 group, 2 groups, 3 groups, 4, and 5. So you have 5 points. Now do the same, but try with 20 groups. So you will have 20 points, and the optimal point will change because your perspective will change. You will see the same points, but visually it will be different. And do the same with 100 points, and it will be different. You will find a new optimal. So it is not a good method to find the optimal amount of groups to split. What I would rather do is to take the points that I suspect are kind of good and run whatever I want to run with that afterwards, a model or a prediction or whatever. Run that and measure how much better is one versus the other with the metrics that you really value. With the ROI or the precision or recall or whatever you're measuring, but get the better amount of groups based on that, not the elbow method, because the elbow method it will depend on how many points you are testing.
Right, so that's the sort of core idea behind cross-sampling as well, right?
I'm not sure what cross-sampling is. What do you mean exactly?
So basically, when you have a sample of data that you're working with, instead of taking disparate samples, break samples into different parts, which is collected different things so that you have sort of enough diversity in the samples, and then go with wherever works best, instead of taking on a group and saying, let's go work with this group of data.
Yeah, it's kind of a similar idea.
One other piece before we go. You're leading 3 mini teams inside of the company, and they're focused on security. I want to just touch on this for a moment because I think security is one piece of machine learning and MLOps in general that does not get talked about enough. What can you tell us about your learnings from leading these teams? How are you looking at security now? How has your view of security and how you do things changed over the time since you started leading these teams?
The most amount of work that we have done on security issues inside the team has been related to the Git repositories. It is very... I already spoke about this, but you can very easily share sensitive data by mistake. Right? Maybe you are writing a code, you commit something by mistake, and it will stick there. You can erase it later, but it will stay there in your history of your repository. And that is one of the virtues of Git. You can retrieve whatever you were working on. If you wrote a password, for example, a password for a database, which is it's a lot of people has done it.
I've done it, which is I've written my authorization code and then had to use like Git Guardian to sort of catch the alert and be like, oh shit, I've exposed information. Go store it in the environment variables.
Yeah, that's very, very common, I think. I have done it also, and I have... but I think the most important thing is to know how to clean that. Because you can. At the end of the day, you have a hidden file on your repository, a .git file. And inside there, you have all of the history of all of the changes you have done. So one quick way to solve that is just delete that file, but that it's not the ideal solution because you will lose all of your project history too. You will still have your working directory, so you can salvage some things, but it's not the ideal solution. So what we did was to use a library called BFG, which stands for big fucking gun from Doom. I don't know if you have played Doom, but there is a pretty huge gun which will obliterate everything inside. So this library does that with Git. You can select which things specifically is it's going to erase. So you can give it a limit on megabytes. Maybe you want to erase everything that has that weighs more than 10 megabytes. Because maybe you accidentally committed a CSV file with data and you want to erase that. So you can erase everything which is too big, because if it's too big, it probably shouldn't be in your Git repository. Git repositories are made to store code, to check differences between lines of code, not between whole files. That's one very, very useful thing about that library. It's a Java library. You can download it and then just call it with jar. And the other very useful thing that you can do is to delete specific commits. Maybe you already know that in a specific commit, you committed a password, or you committed a data set, or you committed whatever that is very sensitive. So you can go ahead and tell that library to erase that commit. What happened to us in our team is that many people had done this in many projects at the same time, and we needed to erase like 200 repos, or we needed to tweak 200 repos. So it wasn't viable to do it one by one, because we didn't even know where we needed to delete. So what we did was to create a mixture of everything, and here I'm going to go back to the multi-language topic. We created a Python file to recognize regular expressions on our repository. So we downloaded the repository. We dived into each repository individually with a simple for. Then we searched for certain keywords like pass, PWD, password, etc., etc., etc. So we found all of the possible security breaches. I say possible because sometimes we had like password equal password. So that was not a security breach. But we managed to get all of the possible security breaches, and then with some batch scripting, we automated that. And then when everything was ready and everything was clean, with our Markdown, we did some reports on that. So at the end of the day, when I run the project, this project goes and takes all of the data in our workspace on Bitbucket and cleans it, and then push force the clean repositories, and then outputs a report with how many security breaches has every repo, how many there are left that we need to still take a look into, because when you use this, you cannot change the main branch or master branch. You cannot change your production branch, because you will break everything. So if the problems are still there, you need to go ahead and fix it, commit something new, and then clean it again. So everything here we did it with multi-language development, and we just used the right tool to do the best tool to do the job that we wanted to do in that specific section.
Incredible. Dude, this has been more than I bargained for. I want to thank you so much for coming on here and teaching me so much that I did not realize beforehand. I mean, this little foray into security was beautiful. Thank you so much. We're going to end it here. And in case anyone wants to get a hold of you, I know you do stream. If somebody wants to watch you streaming, where can they find you?
But yeah, we stream with two friends from two coworkers, and we usually talk about data science related topics. Last time we talked about Great Expectations, and tomorrow we are going to talk about the GPT-3 and so on, so on. We talk about a lot of things related to that. And our Twitch channel is called Encoders with an underscore, _coders. We also have a YouTube channel with just one video. We are working on that. We are very, very busy.
Gotta start somewhere.
Yeah, at least there's one.
Excellent. Well, thanks, man. This has been awesome.
Yeah, and also LinkedIn. If somebody wants to connect, we can talk there.
We'll leave all these links in the description in case anyone wants to check it out.
Yeah, thanks a lot for the invite.
Thank you so much, Rodo.
Yeah, thanks to you.